Hello, welcome to the VHDL Keywords and Syntax lecture. In this lecture, I'm going to explain the commonly used VHDL syntax or keywords. And in VHDL language, there are many different keywords and syntax you need to perform certain actions, but I'm going to cover just the ones that you'll need to complete the projects in this course. So the first keyword we're going to cover is a comment. And in VHDL, a comment is similarly used as any other type of programming language. You'll put this in your actual code to kind of guide you to explain what's happening. A lot of times at the beginning of your VHDL code, you'll have a bunch of comments that explain who wrote the code, the version of it, or any other type of notes. And a comment is denoted by a dash in VHDL. The next keyword is library. And this is used to designate the specific library you're going to be using in VHDL. And different libraries have different packages. And these packages give you different functionality for functions, data types, and as well as different operations, whether it's logical operations or math operations and everything else. If you're a C programmer or an embedded type of programmer, this is akin to a header file or a .h type of file. We also, the use keyword, which is just spelled out like it sounds, USE, is used, and this makes a package available. So we want to define a library, and then we want to define the packages we want to use in that library. The next keyword is entity, and this is, in VHDL, an entity defines your inputs and your outputs of your design. So if you think of VHDL like a shell, the outside is your entity, and internal is the next keyword we're going to cover, architecture. So you have your entity, which defines your inputs and outputs, and this is, the keyword is actually spelled ENTITY, entity. And then you have internally your architecture, which defines what's going on inside your design, and that keyword is defined by spelling out architecture. The next one is generic, and this is a way you can pass certain parameters into your design without actually having to define it as an input or an output. It's a generic. So this is a way, for example, if you want to have an 8-bit adder or a 16-bit adder or a 32-bit adder, you could have a generic that you call size of adder and give it that number. And you don't have to define it as an input or an output. Also, the next one is a port. This defines the interface. So inside the entity, you have a port, and that port defines whether it's an input, an output, or an in/out, or they call it an in/out, which means that you can be an input or an output. You can send and receive on that same line. The next keyword is down to, which this keyword is given by the DOWNTO, or down to, and this is used to define a range. So if you have a specific data type, which we'll cover a little later, you can use the down to say, okay, we have a data type that goes from 31 down to 0. And that just fills all the gaps in between. So that means you have 31, 30, 29, 28, 27, all the way down to 0. So just like it sounds, if you say, I want to go from 7 down to 0, use the down to keyword. And the begin. This is used with a begin-end pair, and these are used kind of all over the VHDL language. So when you have your architecture, you use a begin-end pair to say, okay, here's my architecture, and then I want to begin, and it'll say, okay, everything defined until I see an end is my architecture. As well as if you're using an if statement or any other type of statement or loop, you'll say, okay, if this happens, begin, and then it'll look for the end if. So in VHDL, you'll have begin, end pairs, as opposed to other languages. If you're commonly working with C or any other type of language, you'll have like a curly brace. Instead of that, we have a begin, end pair in VHDL. The next keyword is end, which is just spelled out END. And like we said before, you have a begin, you have an end. This just specifies the end of your begin and pair, which are used various different ways. And the next keyword we have is a map, which is MAP, and this is used to map parameters. So if you have multiple designs inside one VHDL, you might have various files, and we'll do what we call a component instantiation. And this is where you'll map certain parameters. So you'll say, okay, the inputs for my top level entity are mapped to different inputs on my components I have instantiated inside my design. And we'll cover this much later in much greater detail, showing you here's how you do a component instantiation, here's how you map the certain inputs to the other inputs of your other design. And the last one we're going to go through is signal assignment. And this keyword is given by the arrow equals, and this is assigning, it's a signal assignment. So you're saying I have signal A and I have signal B. I'm assigning the value A equal to the value of B. And you can think of it similar when you're if you're working with a circuit. It's like taking a wire and going from A to B. B is now equal to A. It's like we said, just taking the wire and you're connecting to it. You're assigning this signal the value of A. So now we're going to look on our project. We have our button LED project, and we're going to go through and create a VHDL file and give it, using some keywords, we're going to start defining our project. So if you open up your button LED example project in Vivado, you'll want to go into the design sources, right click, and select add sources. And this will bring up the add sources window. And we want to make sure we have the second option selected, the add or create design source. And we want to click next. And from here, we want to click the create file, because we're going to create a brand new VHDL design file. We could hit add files and go out and pull a previously created VHDL file, but we're going to create our own. So we'll select create file, and the file type is, we want it to be VHDL. You can do a Verilog header, system Verilog, but we're going to select the VHDL, and we want to give the file a name. And I'm just going to call it button underscore LED. And typically it doesn't have to be what your entity is, but you want to give it a name that kind of makes sense. So this is our button LED project. We're going to call it button LED. And the file location, you can create it, choose a location and navigate to where you want to create it at. However, I always like to have them local to project, just that way when you go through and synthesize and do everything else with the design, it'll know where to find it. So we'll click OK. And this is just telling us we're going to create a file, button LED. And we'll click finish. And this is going to come up and say, do you want to define the module? And this is where we can define specific ports if we want to have it as inputs or outputs. However, in this case, we're going to actually type those in later. So for right now, we are going to say OK and just leave it as is. So if we look at our button underscore LED, it's saying this behavioral, and that's because that's our architecture, which we'll cover later. But for right now, we want to go ahead and double click on our button LED file, and this will bring up the actual button underscore LED.vhdl file. And so in here, you can see there's already some syntax they have given. So they give you this top level type of description, and you can see the keywords we have are the comments. We've got this library, and it gives us the library IEEE, and we're using the IEEE Standard Logic 1164 package, and it gives us an entity, which is the name of the file, button underscore LED. We have to define the port, what are the inputs, what are the outputs, and then it also defines the architecture for us. So it gives us the architecture, which we're calling behavioral, of our button LED and then it says begin and behavioral. So this is just the rough shell of our entity and architecture of our button underscore LED file. And so that is just a covering or a summary of the keywords you'll see in VHDL. And as you can see, once we created this file in Vivado, you can see a lot of these keywords that are showing up.